We have a concrete idea of how the universe developed from an original singularity, occurring 13.8 billion years ago. We can trace the origins of the first stars, galaxies, and black holes, reconstructing the grand tapestry of cosmic evolution. However, one persistent question remains. What really happened before the Big Bang? Stephen Hawking, one of the most influential theoretical physicists of our time, proposed an intriguing answer, asserting that, in fact, there was nothing. This concept is as fascinating as it is unsettling because it implies that even time itself began with the birth of the cosmos. However, some researchers have a different and stimulating vision. For them, the Big Bang does not represent the beginning of everything, but is just one of countless Big Bangs occurring in a perpetual cycle of expansion and contraction. This perspective suggests that our universe is not the whole picture but rather a link in an infinite chain of universes. And there is concrete evidence that makes this hypothesis more than mere speculation. Recently, the James Webb Space Telescope made a surprising discovery. It revealed clues suggesting that our world is currently merging with other universes. In the 1920s, astronomers began studying distant galaxies and realized something unexpected. Most galaxies were moving away from us. This observation sparked a wave of speculation that Earth might be at the center of the universe. However, experts soon became wiser. Further observations showed that not all celestial structures were involved in this mass galactic exodus. In fact, our Milky Way and the Andromeda Galaxy are moving toward each other, with a merger expected in just over 3 billion years. In the past, the journey of galaxies seemed like an unsolvable mystery, like the plot of a science fiction novel. However, after decades of investigation and in-depth studies, experts have uncovered the true reasons behind the strange movements of galaxies. We now know that it's not the galaxies moving through space but rather space itself that is constantly expanding. The expansion of the cosmos, however, is not as simple as it might seem at first glance. It has no central starting point. This means that everywhere in the universe, it appears that entities are moving away from us. In other words, it always seems like you're at the center of the universe, from which all other structures are fleeing. Moreover, scientists have discovered that not only is space expanding, but the rate of expansion is actually increasing. In other words, the farther a galaxy is from us, the faster it moves away. Recent studies have shown that about 97% of the galaxies in the observable universe are moving away from us at a speed greater than the speed of light. But how is this possible? Doesn't this contradict Einstein's theory, which states that nothing can exceed the speed of light? Actually, no. Einstein's theory applies only to empty space. In reality, galaxies are stationary in space, and their movement depends on the expansion of space itself. Thus, no cosmic speed limit is being violated. In fact, Einstein himself recognized that speeds greater than the speed of light are possible within the limits of space. In the context of the Big Bang, astronomers generally believe that cosmic expansion began precisely with this event. This is unsurprising, as space formed along with matter and time from an original singularity. How could something expand that didn't yet exist? We often imagine the Big Bang as a sudden event where the cosmos literally exploded into existence. According to this hypothesis, the origin of everything that has existed, exists today, and will exist in the future dates back to that unimaginable, hot, and dense point 13.8 billion years ago. We might imagine the singularity as a tiny dot in the proverbial void, but how does this image reconcile with the idea that the universe is infinite? Some experts point out that the cosmos must have always been infinite. In other words, the Big Bang did not happen in a specific place, but everywhere. This also means that the first galaxies did not form in a specific region of space but throughout the universe. Similarly, it seems that matter appeared everywhere in the cosmos at a certain point. Nevertheless, the common image of the Big Bang leaves some crucial questions open. What caused something to suddenly appear from nothing 13.8 billion years ago? Can something arise from nothing? Was there a trigger, or was it pure coincidence? We simply do not have clear answers to these profound questions, which have always been the subject of intense debate among experts. The point is that the Big Bang theory alone does not explain all the features of the universe we can observe today. Among these, for example, is isotropy, meaning that observations are always the same, regardless of the direction of observation in space. This is where cosmic inflation comes into play. It refers to a phase of extremely rapid expansion of the universe that is thought to have taken place immediately after the Big Bang. During this phase, the universe grew from something tiny to something significantly larger in less than a trillionth of a second. What powered this elementary process? Researchers point to a mysterious force, believed to still drive the accelerated expansion of the universe: dark energy. Dark energy is a fascinating and elusive concept. It makes up about 68% of the universe, yet, despite its prevalence, it remains an enigma. Discoveries from the James Webb Space Telescope further fuel this theory, raising new questions and possibilities. At this point, it's worth noting that while dark energy and its associated fields are a possible cause of the cosmic inflation trigger, we do not know if there is a link between the dark energy of then and that of today. However, dark energy is currently considered the driving force behind the accelerated expansion of the universe in modern space research. Although this mysterious form of energy has had a fixed place in the astronomical research world for over 25 years, its existence has yet to be experimentally proven. In this context, some scientists believe it is possible that dark energy is not driving the accelerated cosmic expansion, but something we know only from wild science fiction films. Incredibly, a study published on December 12, 2023, in the Journal of Cosmology and Astroparticle Physics concludes that what our instruments perceive as the expansion of the universe could actually be the result of universe mergers. To understand the context of this unconventional hypothesis, we must briefly detour into the world of the Hubble constant. It indicates the rate at which the universe is expanding, but unfortunately, it contains a gigantic puzzle. If we determine the Hubble constant based on the cosmic microwave background, we get a value of 67 km per second per megaparsec. However, when experts consider supernovae, red giants, gravitational lenses, and variable stars like Cepheids, the Hubble constant suddenly becomes 73 km per second per megaparsec. In other words, the universe is expanding much faster than it should. But how is this possible? According to our theories, space should expand at the same rate everywhere. A possible explanation is that past measurement results have been obscured by extra-universal elements that interfere with our observations. In other words, cosmic mergers may influence the observation of the universe in such a way that the expansion is perceived as faster than it really is. According to this theory, we may be at the center of a large number of universes merging in a moment of cosmic madness. If dark energy plays a role in triggering this accelerated expansion, we may be able to measure changes in the universe's expansion rate over time. Therefore, our understanding of the speed at which the universe is expanding could be based on a kind of optical illusion caused by phenomena we do not yet fully understand. In fact, the merging of universes could represent a completely new paradigm, in which the universe is not static but is constantly moving, joining and separating galaxies and universes in ways we cannot yet fully comprehend. We may be facing a cosmic event happening on a dimensional and temporal level unknown to us. Scientists wonder if our cosmic ancestors were able to perceive similar events in their time and if they might have interpreted them differently, producing myths and legends related to the creation of the universe and its expansion. Our consciousness may also be in a state of constant transformation, influenced by processes that completely escape us. Moreover, the merging of universes could also be the result of a quantum connection. In this context, the idea of a multiverse where different universes coexist and interact becomes not only plausible but also fascinating. In fact, some theoretical physicists believe that collisions between universes could trigger catastrophic events on a cosmic scale, generating explosions of energy and the creation of new matter in a cosmic dance of creation and destruction. This perspective offers us an intriguing glimpse of what we might discover in the future. Theoretical physics, constantly evolving, could give us access to a deeper understanding of the nature of the cosmos and its origins. The insights we've gained about the universe around us have been radically redefined in recent decades, and science invites us to push beyond the boundaries of our knowledge. With every new discovery, we realize there are far more questions than we could have ever imagined. Cosmological theories do not provide all the answers, but they encourage us to explore the mystery of the universe and discover more and more secrets along the way. Our curiosity is the driving force behind our search, and every new discovery is a piece of a larger mosaic that continues to take shape. Science is ever evolving, and so is our understanding of the universe. Even if cosmic merging remains only one of many possibilities, it pushes us to reflect on our existence and the nature of the cosmos around us. We are the products of a universe in constant transformation, and our journey of discovery is just beginning.